Students, today we're going to create a triangle and do some cool stuff with the triangle. The program you see right now on the screen, this is called GeoGebra, and we're going to hopefully get some computers into the classroom and mess around with this thing. It's kind of an interesting program. Now, the one thing you might want to consider doing is, it's spelled G-E-O-G-E-B-R-A, GeoGebra. And just Google that, and you can find it. It's a free download. You can install this on your computer anytime you want. And it's pretty cool, as you can see. I'm going to show you some stuff. But today we got a regular triangle. Now take a look at this triangle. And now the neat thing with GeoGebra is it's dynamic. I can move this thing around. I can move this point around, you see. And I can do anything I want to with this triangle. So one of the things that I have done with this triangle is I've created a bunch of perpendicular bisectors for the side AB, side BC, and side CA. So watch what happens when I click on those. This is a perpendicular bisector of point AC. Okay? See, as I move this thing around, it moves with it because that's a perpendicular bisector. It's always going to remain at a 90-degree angle with line AC or segment AC, and it's always going to split segment AC into two congruent segments. So I've done the same thing with the second side. This is the perpendicular bisector for side AB, and this is the perpendicular bisector for sides BC. Now, of course, what do you notice when those points, when I move these things around, what do you notice about that perpendicular bisector? Well, take a look at that. They always meet at one point, don't they? All three perpendicular. Now, sometimes they're not inside the triangle, are they? Look at here. It's outside the triangle here. But those three lines, those three perpendicular bisectors, always meet at one point. Now, there's something else that's really cool about this thing. And if I click on this point, this is point D. This is the center, okay? Now, if I make a circle and I just create, this is a center of the circle, and I go up to point B as the edge of the circle. That's how I created this circle I'm going to show you here. Take a look at this. You see that circle? Even though I made that circle from here to here, okay, you notice it goes from here to here also, and it goes from here to here. And watch what happens when I move this thing around. You notice that circle hits every single one of these vertices. It always, points A, B, and C are always on that circle. And if I get rid of these three lines, you can see it even more clearly. And if I get rid of that point D, then look what happens here when I move point C around. That circle always lines up with A, B, and C. Now, I didn't create this circle using A, B, and C. I created the circle using D as a center and point B as the radius. So DB is the radius of the circle. But somehow or other, DC and DA are also radiuses, okay, or radii. And there's something even more cool about this. And by the way, if we can get the computer carts, we're going to be doing the same thing in class next time we meet, or pretty soon. So if we do something, let me do something else here with this, and I'm going to get rid of the circle, and now we're back to the triangle. Watch what happens when I create angle bisectors, okay? So watch what happens. I go, here's H is an angle bisector, okay? Line H. And that's, I made that by just creating an angle bisector of CAB, okay? And as you can see, every time I move this thing around and create a different angle, that thing stays inside there, and it bisects angle CAB no matter what angle CAB is. Well, I did that with the other two angles in the triangle. There's ABC and BCA. So and notice what happens with those three angle bisectors. What happens? They meet at the same point, at one single point. Well, there's something even cooler about that. Watch this. I'm going to click on this. That's point E. Okay? Now I also created another line here. This is a perpendicular line from point E to the side. Okay, this is from point E. It's perpendicular to side AC. And then I created another point where those two intersect. This is point F. And so I created a circle with E as a center and F as one point on the circle. And let's take a look at that circle. What's true about the other two sides? Okay, and let's get rid of all these lines. And now remember, I made this. This is a perpendicular line from E to F, or the EF is perpendicular to AC. But notice, and so of course it touches AC. But notice it touches also BC and AB. And no matter how I move this thing around, okay, that's where it goes. Now, point E, just so you know, and let me get rid of that right there. Point E is what we call the incenter. Okay? And this is the inscribed circle. Point E is formed by all the three angle bisectors. Now point E is always going to be inside the circle. Okay? Or inside the triangle rather. So no matter what I do, no matter how I distort this triangle, point E is always in the triangle, and the circle always remains touching all three sides. That's kind of cool. So let's try something else here. Back when I was talking about, let me get rid of point E. Remember I was talking about point D was formed by the perpendicular bisectors of all three sides. And there was that circle that I made that touches all three vertices. Okay? No matter what I do with that circle, touches all three vertices. So that's just a really cool thing that happens with the. This is the, by the way, this is the circumcenter, and this is a circumscribed circle. So we'll talk about that more in class, and I just thought you might be interested in seeing that. So thank you very much.